Welcome to this short teaching video on how to properly use entry points and justifications when working with F-prime analysis questions on the AP exam. These are very common and typical problems in the AP exam, but yet students often perform under their ability levels for a multitude of reasons. Most of these reasonings can be solved by using the teaching strategies that can be found in the F-prime analysis module from Applied Practice. In this video, we're going to put these teaching strategies to practice to help teachers and students alike have a better understanding of how to not only approach AP problems, but also give correct reasoning, ensuring that they will achieve maximum points. Question number 1 says, on what open intervals contained in -3 less than x less than 4 is the graph of f both concave down and decreasing? Give a reason for your answer. One of the things that we're going to use as a strategy is going to be to answer this question that's given to us before we worry about the actual graph or any other information that's given to us in the problem. I'm going to go ahead and I'm going to underline the actual question that was asked. In this case, we're trying to find out when f is concave down and decreasing. One of the big mistakes that students make is they try to answer the problem while simultaneously looking at and interpreting the information that's given to them. This is a very dangerous approach and often leads to common mistakes that could be corrected if we isolate the question before we look at the other information. Here we're told that f is concave down, and by translating this, we know that f is concave down when f prime or f double prime is negative, less than 0. But we're also trying to find out points on the graph where f is decreasing. And we know that f is decreasing when f prime is less than 0. This is called finding an entry point and translating the question before looking at the other information that's given to us in the problem. So we know we're trying to find an interval where f prime is negative and f double prime is negative. And notice in this case, we're given a graph of f prime. So if we're going to find an interval where f prime is negative, we're looking for points on this graph where the graph itself is below the x-axis. And so we know that we're only going to be considering intervals between -2 and 1, as well as from 1 to 4. And the interval from -3 to 2, the graph of f prime is above the x-axis, therefore f prime would not be negative, and we can eliminate that portion. Now, not only are we trying to find when f prime is negative, but we're having to also find when f double prime is negative. Well, since we're given a graph of f prime, we relate that f double prime is the derivative of this graph. Graphically speaking, another word for derivative would be the slope. So we're trying to figure out of this dark blue line graph, when is the slope of this graph also negative? And we know that the slope of this graph is negative when the graph is decreasing or going down. And I'm going to highlight these in red, and we can quickly tell that the graph of f prime is decreasing, meaning f double prime is negative between -2 and -1, as well as from 1 to 3. And so our final answer is going to be from -2 to -1, as well as from 1 to 3. And the AP exam wants us to give a reason for our answer, and that's quite easy to do because our interpretation, our translation of the problem is actually going to be our reasoning as well. So we can say that our answer is between -2 and -1, as well as from 1 to 3, simply because f double prime is less than 0, and f prime also is less than 0. So by using those translations and entry points, you're helping avoid mistakes from picking the wrong intervals, but you also have your reasoning already given to you in the problem. Let's try question 2. Find all x coordinates where f has a relative maximum. Give a reason for your answer. So once again, we're going to go ahead and underline the question. And the question was, when does f have a relative maximum? We're using the table that's given in the teaching strategies. We know that there's a couple things that we have to check for. The first thing we have to check for is if f has a relative maximum, then f prime must be equal to 0 or possibly undefined. But not only does that have to happen, but to be a relative maximum, f prime will have to change signs specifically from positive to negative. F prime will have to change sign from a positive value to a negative value. And now if we go back to our graph, and we'll go ahead and erase these previous marks. If we go back to our graph, then the first thing we're looking for is when f prime is 0. And we're going to recall that this is a graph of f prime, so we're looking for when the y value of the graph is 0, and that occurs when x is negative 2, when x is 1, and when x is 4. But not only does f prime have to be 0, f prime needs to change sign from a positive number to a negative number. We're not concerned with the direction of this graph. Since this is a graph of f prime, we simply want to know when the value of f prime goes from a positive number to a negative number, and we can see that before negative 2, the graph of f prime is a positive y value. Between negative 2 and 1, the graph of f prime is below the x-axis, meaning it's a negative value. And then from the point 1 until x is 4, the graph of f prime is below the x-axis still, and so f prime is negative. And the only place where the graph of f prime goes from a positive value to a negative value is when x is negative 2. And there is our answer. Our answer is going to be x equals negative 2. And our reasoning, just like we did in the first question, that our interpretation is going to be our reasoning. X equals negative 2 is our relative maximum, and this is because f prime will change signs from positive to negative. F prime changes sign from positive to negative. This simple one-sentence answer is the reason that we need to give for a question like this. And finally, question 3 asks, find the x-coordinates of all points of inflection for the graph of f. Give a reason for your answer. Once again, we're going to go ahead and underline and identify the question that the problem is asking, and we're going to answer this and translate it in isolation before we start considering the graph or whatever's given to us in the problem. And so we know that you have a point of inflection, according to our table, that a point of inflection occurs when the first step is to identify when f prime is 0 or undefined, f double prime, and then secondly, f double prime needs to change signs. F double prime changes sign. And we'll notice that in this case, it doesn't matter if the sign changes from positive to negative or vice versa. Any change in sign will create a point of inflection. So going back to our graph, if we erase the previous work, we're going to see that the first thing we're checking for is when f double prime is 0 or undefined. Remember, this is a graph of f prime, and we're trying to find out something about f double prime, which is the derivative of this graph. So we're trying to find out when the derivative of this graph, or the slope of this graph, is 0 or undefined. And we see that we have a slope of 0 when x is negative 1, when x is 1, and again when x is 3. But not only does the slope of this graph, not only does f double prime need to be 0, but f double prime needs to have a sign change. So considering f double prime, which is the slope of this graph, we see that before negative 1, the slope of f prime is negative. F prime is decreasing, meaning it has a negative slope. Between negative 1 and 1, f prime is increasing, meaning that f double prime is positive. And from 1 to 4, we see that f double prime is decreasing again, meaning f double prime is negative. So we see that f double prime changes signs when x is negative 1. F double prime goes from a negative value to a positive value. And we also see that f double prime changes signs when x is 1, because f double prime goes from positive to negative. And then we see that f double prime changes signs as well when x is 3, because f double prime went from negative to positive at x equals 3. So our answer is going to be 3 different x values. X is going to be negative 1, x is going to be 1, and x is going to be 3. And our reasoning is because f double prime changes sign, and we do not need to indicate which way it changes sign, just that it changes signs. So using this interpretation, this entry point, helps us identify the correct first step to enter the problem, but it also gives us the correct reasoning and justification on the back end of the problem as well. And by using this strategy, it helps us not make mistakes with finding the correct answers, as well as give us a blueprint for how to give correct reasons and interpretations.